All right, so I want you to remember the function machine because it's really, really going to help us. So what I want you to write down, there's a lot of definitions and stuff like that, but kind of the big idea is we have a new operation. And it looks like the word fog, but that little open circle is smaller than a letter O, okay? But it's not a dot. Dot means times. We're going to learn something called a composition of functions. And so my function machine is going to be a good visual for us. Sometimes you see it written like this. Sometimes you'll see it written like this. And sometimes you'll see it like this. I need you to be comfortable with all the different ways that you'll see it. The big idea is that a composition of functions is where we put one function inside another function. So what we did yesterday is we added functions, subtracted, multiplied, and divided functions. Today we're doing what's called a composition. And a composition, again, is where you put one function inside another function. One other thing is, how do you find domain? To find domain of a composition of functions, here's what you do. It's got a few steps to it. First, find the domain of the inside function. And I'll explain what this is in a moment. Okay, to find the domain of a composition, the first thing you do is you find the domain of the inside function. The second thing you do is you find the domain of your answer. Then you look for the intersection. Now, again, and the intersection is the domain, okay? So I realize that might be a little muddy, a little confusing, and that's okay, because that means you're learning something new. Just stay with me, and we'll work on that actually on the backs. No, we'll do it in problem 4. But problem 3, what we're going to do is we're going to start with numbers, and then we'll get more abstract. Just like I did with the function machine. We put 2 in, we put -1 in, but then we did x minus 3, we did x squared plus 1. Yeah. Great question. It's just like we did it yesterday. If you have lines, the domain is all real numbers. If you have parabolas, the domain is all real numbers. If you have any polynomial, x to the 3rd, x to the 4th, x to the 5th, all real numbers. The only 2 functions up to this point in this school year, we do square roots. You put the radicand greater than or equal to 0. Fractions, the denominator is a 0. So we're going to use that here. All right, so let's look at problem 3. It says let f of x equal x minus 5, g of x equals x squared. All right, so do you see this is the open circle thing I'm talking about? And what I like to do is my preferred method, if I can go back up here, I almost always write it like this, but sometimes if I'm getting a worksheet off the internet, they've used the little fog notation, so I just need you to be comfortable. And our book uses it too. So all we're going to do is we're going to rewrite it. So when I see, and the way we read it is g of f of -3. And you always start with the inside function. So this is a beautiful connection to what we did yesterday. So what I'm going to do is I'm going to do f of -3 first. F of -3 means I'm going to plug in x is negative 3 into the f function. So that's negative 3 minus 5, which is negative 8. So does everybody see why f of negative 3 is negative 8? You just plug in x is negative 3. What's the output? Now I go to the g function. Okay, now I actually want to find g of negative 8. So I go to g, and g says, don't think of it as the letter x. Think of it as input. So when I go to g, this is actually telling me, take the input and square it. So if I take negative 8 and I square it, what do you get? 64. Yeah, Marissa?
But if f of x is x minus 5.
Yes, f of x is x minus 5. So when I wrote g of f of negative 3, I'm ignoring g, it stays out front, okay? And when I do f of negative 3, that means what is the output when the input is negative 3? Okay, f of negative 3 means what's the output when the input's negative 3? So negative 3 minus 5, I replace f of negative 3, that whole thing, with a negative 8. Does that make a little bit more sense? Yeah.
Where'd you get 64?
Because g says square your input. So what's negative 8 when I square it? That's where it came from. Okay? All right, so now let's do the got it.
So that's your final answer.
That's my final answer is 64. So g of f of negative 3 actually has a value of 64. Yes, then I'm done. So now, in the got it, let's just rewrite the fog notation, okay, the composition notation. And let's write this as f of g of negative 3. You always start with the inside function. So I go to negative, or g, so g's up here. What does g say to do to the input? Square it. So what's g of negative 3? 9. So this is going to be f of 9. So once you find g of negative 3, it disappears. That whole thing disappears. And I call it 9, because that's what it is. Now, I go to the f function, and f says input minus 5. So what's that? 4. Nice. Okay? Now, I want to pause a moment and ask you a question. Do you know how in Algebra 1 and even earlier this year in Algebra 2, we've talked about things that were commutative. We said addition is commutative. 3 plus 5 is the same as 5 plus 3. Multiplication is commutative. 3 times 5 is the same as 5 times 3. Subtraction is not commutative. 3 minus 5 is not the same as 5 minus 3. Division is not commutative. 3 divided by 5 is not the same as 5 divided by 3. So look, I had you do g of f of negative 3, and then I switched the order and did f of g of negative 3. Is the composition of functions commutative? No, okay? So, let's write this down. Function composition is not commutative. What that means, and I'll step out of the way here for you. What that means is the order matters, okay? The order matters. You do the inside first.
Okay.
Yeah, you do the inside first, okay? Great question. All right, so here we go. Problem 4. Now we're not going to deal with numbers. We're going to do like my function machine where we put x minus 3 in, we put x squared plus 1. So I want you to imagine my function machine as we're doing these. And I'll try to break it down as simple as I can. So in letter A, I would first rewrite this This really means f of g of x. So g of x is the inside function. So because it doesn't have a number, all I'm going to do is replace g of x with x squared minus 2, okay? So when it's just an x, there's no numbers to be putting in, you're going to replace the entire inside function with what it is. So you guys, I'm going to do lots of examples of these. So even if after the first couple you're confused, hang on, and I hope to clear it up by the time we're done with the notes. So now, I'm going to go to the f function. And what I'd like you to do is under f, I want you to draw an arrow from x. And we're going to call that x, input. Just like we did with the function machine. So here's how I want you to rewrite it. This is 2 times my input plus 7, okay? And put that under there if you can squeeze it. When f of x equals negative 2x plus 7, what that means, x is just a placeholder for inputs, okay? So this is negative 2 times my input plus 7. So when I go to do f of x squared minus 2, what's my input now? What am I trying to put into f? Jacob?
X squared minus 2.
Beautiful, okay? My input is what's ever inside the function, okay? So watch what's going to happen. This is negative 2 times my input plus 7. I'm not done, but this is your initial step. And then we're going to tidy it up however we need to. So I know the distributive property, right? So I can distribute the negative 2 and get negative 2x squared plus 4 plus 7, right? If I use the distributive property. And then I want to see, is there anything else I can do? Yeah, I can collect like terms. That's negative 2x squared plus 11. Now, I'm not going to talk deeply about domain here. I'm just going to do it briefly. What I said, what I had you write down is, you find the domain of the inside. The inside's a parabola, right? The domain of a parabola is all real numbers. My answer is a parabola. It doesn't matter that one's up and one's down. The domain is all real numbers. So the domain is just all real numbers. And this one is not very interesting to talk about. It's just all real numbers. All right, so now, letter B. It'll get more interesting, not even in problem 5, but when I hit problem 6 and 7, that's when domain might make more sense. But we're going to spend a third day on 6-6 tomorrow, really honing in on compositions. All right, so here we go. G of f of x. So I'm going to replace f of x with negative 2x plus 7. So f is gone. We're not going back there, okay? Once you replace it, it's done. Now, I want g of negative 2x plus 7. So I want you to come to the g function, and if x is the input, what g is saying is take your input and square it minus 2. Okay? That's what g of x equals x squared minus 2 is. Your input squared minus 2. So my input is negative 2x plus 7. I'm going to square it minus 2. Then you can see all the times that we have practiced something, a quantity squared. Remember how we foiled and foiled and foiled? Especially back in Algebra 1. It's because you needed it later. You didn't know it then. So that's negative 2x plus 7 times negative 2x plus 7. And then there's this little minus 2 out there. So let me give you a head start. Foil it. And then you got that minus 2. Don't lose it. And then collect like terms. literally negative 2x. It's negative 2 times input.
Okay.
And this is
The
input
x.
squared. The x comes out completely.
The x is the input.
Yes. Yes, you got it. Alright, I'm going to continue this one up here. So I get 4x squared. Negative 14x minus 14x is minus 28x. Plus 49 minus 2. So you should be getting 4x squared minus 28x plus 47. Did you guys get that? Or are you getting it now? Again, the inside function is a line, so it's all real, domain all real numbers. My answer's a parabola, it's all real numbers, so the domain is all real numbers, so not very interesting. Alright, when you're ready, flip the page, and I want you to try problem 5. Don't do 6 and 7 yet, okay? But let me give you a head start. See if you're starting to get the hang of it. No. When you square something, you gotta remember, there's no x squared. No. Okay. X is the input, so that's saying you take your input and square it. So let me go over it, okay? Alright, let me go over this one in letter A. This is f of 2x minus 4. And you guys, Katie had asked me a really good question earlier. And I'm not sure if you heard it, but if I go to f of x, the x is going away completely. The x really isn't the letter x, it represents your input. So when you're doing the f function, when it says f of x is x squared, that means f of x is your input squared. So this is my input is now 2x minus 4, and I square it, which is 2x minus 4 times 2x minus 4. Composition of functions does take a little bit of getting the hang of it. So, try to just remind yourself as you're feeling frustrated, like I'm going to get it. I don't get it yet, but I will get it. So this is 4x squared. The outer is minus 8x. The inner is minus 8x. So that's minus 16x plus 16. Again, the domains are not very interesting here. The inside function is 2x minus 4, so it's a line. It's all real numbers. My answer is a parabola. It's all real numbers, so it's all real numbers. All right, let's try letter B. If I have g of f of x, so the inside function is f. So I replace f of x with x squared. Then you go to g, and maybe rewrite it like I'm doing it up here. Rewrite the x like this, so that it's 2 times the input minus 4. Some students find that enormously helpful. You do it if it helps you. If you don't need it and you're consistently getting the right answers, then you don't need to do it. Here, my input is x squared. So it's 2 times x squared minus 4. There's no like terms. I'm done. The inside was a parabola. The domain is all real numbers. The answer is a parabola. The domain is all real numbers. You can either do negative infinity to infinity, or the capital R with the double line through it. All right, so I don't want you to really ask too many questions at this point because I don't think I've done enough to clarify. So let's do problem 6. In problem 6, f of x equals the square root of x, g of x is x plus 2. So this is f of x plus 2. And you can put that extra step or not. You do it whatever you need. So the fog notation needs f of g of x, and that's how we say it, f of g of x. So I have f of x plus 2, but f of x is saying do the square root of your input. So that's the square root of x plus 2. All right, now the domain is interesting. All right, so here we go. My inside domain is all real numbers, okay, because that's a line. But the domain of my answer, I have to do the radicand greater than or equal to 0 because I can't have a negative under a square root. And we talked about that yesterday. Remember, I had the caret, square root. So I subtract 2, and I get x is greater than or equal to negative 2. So my domain, an intersection means if I drew both of these, I would have a full number line drawn for all real numbers. This one would be negative 2 and to the right. An intersection means where do you see both of them shaded at the same time? Well, that's going to start at the negative 2 to the right, like that. So then that's my domain. So it does happen to be the same as the answer, but sometimes the inside will have something wacky going on. All right, let's try this one. G of f of x. So this is g of the square root of x. So the g function says input plus 2. My input is the square root of x. That 2 is not underneath the square root because it's input plus a 2. So now the domain of my inside would be x greater than or equal to 0 because that's the square root. The domain of my answer is also x is greater than or equal to 0. So my domain would be 0 to infinity. All right, problem 7. Try this one, okay? At least get part A done, because I think based on our function machine, you should be able to do it. I just wrote it on the board. So we're going to do f of g of x. G of x is x minus 5. F says 1 divided by your input. All right, hang tight real quick. So that's 1 over x minus 5. My domain, the inside is all real numbers, but my answer is x can't be 5. And you can write it like that, but it's a little bit neater to say if it can't be 5, that's negative infinity to 5, parenthesis, union, parenthesis, 5 to infinity. All right, if you need a break, go ahead and take a break. When we come back, we've got an agenda for plus. because there was no square root here.
Okay.
You see, there was a square root, so that's why we did square. There's no square root
Yes.
in this problem.
Oh, because it's not a subscript. Okay. Or
Yeah.
superscript, or whatever it's called.
Yeah.
Oh, okay.
Okay.
I thought it was like a superscript. I thought you had to like turn it into like the it's like the whatever you call it. Like
Yeah, the exponent.
Yeah, the exponent.
Yes, sir.
I did take a quiz.
Yes, you go down to the testing center. It's on the first floor of the LC. And Bennett, if he can't find it, ask him to look in period 7 as well as 6. Okay. Ooh,